Hello, this is a Group 6 presentation composed of Pori Abdahi, Tushar Sharma, Winfat Fang, and me, Pilar del Rio, about TESS, Transited Exoplanet Survey Satellite, our presentation Exploring Distant Worlds. So, for the introduction, TESS was launched on April 18, 2018. It's a NASA mission focused on discovering exoplanets using the transit method. So, more about the history of TESS. Concept and proposal. Between 2006 and 2010, the idea for TESS was developed to build on the success of the Kepler Space Telescope by focusing on nearby stars. Development. Between 2011 and 2016, NASA approved the mission in 2013. TESS was constructed by Mid-Kavli Institute for Astrophysics and Space Research. Here on the slides are some images. You can see some of the process of the construction of the telescope. Continuing on the history of TESS, so as it was mentioned, its launch was in April 18 in the year 2018. TESS was launched aboard the SpaceX Falcon 9 rocket from Cape Canaveral Space Force Station. Key milestones from 2018 until the present. TESS began its mission to survey over 200,000 stars for exoplanets. I will leave you now with my teammate Winfat to continue the presentation. Thanks.
So, why TESS was developed? This is because TESS was developed to address some of the limitations of earlier missions like Kepler. Its larger field of view and higher sensitivity allow it to survey border regions of the sky and focus on brighter and near stars. Here you can see some comparative diagram illustrating these improvements. TESS has advantage over previous missions. For example, TESS has a much larger field of view compared to Kepler, enable it to cover about 85% of the sky. Additionally, TESS is designed to detect smaller planets with higher sensitivity, making it more effective at identifying Earth-sized and super-Earth-sized planets in the habitable zone of their star. Let's talk about TESS instrument and components. TESS is equipped with 4 wide-view cameras, each with a 24° x 24 degrees field of view, designed for large area sky survey. This camera detects exoplanet transits by measuring small change in starlights. For the detectors, each camera uses advanced optical lens to focus starlight onto charge-coupled device, which record light intensity and detect brightness variations. For data handling, onboard system process this data to identify potential transits before sending it to Earth for detailed analysis. Additionally, TESS instruments are kept at optimal temperatures through a passive thermal control system, ensuring consistent performance.
Have you ever wondered about the purpose of TESS? The primary goal of TESS mission is to discover exoplanets around nearby stars, with a particular focus on smaller, Earth-sized and super-Earth-sized planets. These planets are considered prime candidates for having liquid water and potentially supporting life. Data collected by TESS is crucial for follow-up studies using ground-based telescopes in future missions like James Webb Space Telescope, which will analyze these planets in greater detail. Let's dive into some of remarkable discoveries made by TESS. Since its launch, TESS has been a game changer in field of exoplanet research, identifying thousands of exoplanet candidates. Among these, Many have been confirmed as new worlds orbiting nearby stars. Some of standout discoveries include TOI 700, an Earth-sized planet located in habitable zone, and LHS 1-140, a sub-Neptune-sized planet that offers exciting possibilities for atmospheric study. These findings are not just numbers, they provide crucial data for understanding planetary systems and guiding future research endeavors. TESS has greatly benefited from experiences and lessons learned from earlier missions, particularly the Kepler and Hubble space telescopes. Kepler mission's limited field of view was a key factor that led TESS to adopt a much broader survey strategy, enabling it to cover about 85% of the sky. Kepler's data management challenges also drove enhancements in TESS's onboard data processing capabilities, allowing for more efficient handling and analysis of vast amounts of data. Additionally, TESS has been specifically optimized to detect smaller exoplanets more effectively from Hubble Space Telescope. TESS inherited critical importance of follow-up observations for detailed atmospheric characterization, as well as the value of using diverse observational approaches. These advancements have collectively made TESS a more effective and comprehensive mission for surveying exoplanets.
Myself Tushar Sharma, and I will be covering the next slides of the presentation, starting with scope and overview of targets of TESS. TESS targets bright nearby stars within 300 light years of Earth, focusing on various stellar types including Sun-like stars, red dwarf, and other main sequence stars. Notable systems discovered by TESS includes TOI 700 featuring an Earth-sized planet in its habitable zone and LHS 1140, a sub-Neptune-sized planet with intriguing atmospheric properties. Additionally, the HD 21749 system includes both a system Neptune and a dense atmosphere and a super-Earth offering valuable insight to atmospheric compositions. Future of TESS. Extended mission and observation data analysis and follow-up, contribution to exoplanet catalog, impact on future missions, scientific and public outreach. TESS missions is far from over. Its extended mission phase will continue to expand its sky survey and refine its exoplanet catalog. Ongoing data analysis will identify and confirm additional exoplanets, guiding the planning of future space missions and observation. TESS will continue to engage both scientists and the public with its discoveries, promoting future research and fostering public interest in space exploration. Coming up to conclusion of this whole presentation. In conclusion, TESS has significantly advanced our understanding of exoplanets and their diverse characteristics. Its wide field photometry has resulted in identification of over 7,200 exoplanets candidate, with 543 of them confirmed. These discoveries include a broad array of exoplanets such as Earth-sized planets in habitable zones, hot Jupiter, sub-Neptune, and etc. TESS mission has enriched our knowledge of planetary system and set the stage for future discoveries, driving forward the search for life beyond Earth. And with this, I would like to end our presentation at a very good note, and following up will be any kind of references that we have used are listed. Beckerly, T. Burke, CJ, and Pettigrew E., one of the most used journal that we have taken the data from, and other are listed as follows. Thank you and have a good day.